अब हाँ, जब 7 सेकंड दे रहे 7 सेकंड में डिले रहता है। यार सुना था। हाँ, से चलता ही रहेगा ये 7 सेकंड का होता है। वो एक न्यूट्रल पॉलिसी नहीं सर। ऐसा है कौन है? हेलो। लैग करेगा ना?
आवाज कहाँ से?
इसमें आ रही है।
हाँ सोने दे।
हेलो।
बहुत ज्यादा है भारी आवाज। सही है।
देखिए एक्चुअली हम यही हैं, हमें पता है कि कहाँ से।
सही आवाज है। वो ये सब बात है। उसको बंद कर।
हेलो। हेलो।
आवाज नहीं है। हमसे मैं तुम देख लेते हो जैसे ये इसमें देख लेते हैं सब।
सही थी।
अच्छा।
हेलो।
समस्या उसको हम करना चाहते हैं तो इससे
हेलो। Good morning, ladies and gentlemen. I, Dr. Tej Pratap, Joint Organizing Secretary of International Conference on Innovations in Mechanical and Materials Engineering, IMME 2022, feel privileged to extend my warm welcome to all the dignitaries, guests, and delegates with great joy and immense exultation. This conference is conducted in the hybrid mode. The idea of this conference is to bring together the leading activities, researchers, engineers, and industrial professionals to share the experience and research results of various streams more closely. We also believe that it will help us to understand the real life problem very closely and work together the resolution of those problems by interacting the experts from multiple ex- streams related to mechanicals and materials engineering. Without taking any more time, I would like to request all the respected dignitaries to come forward for the lighting lamp ceremony for and Ma Saraswati Vandana. Sir, please. Let's pray to the God that may continue to burn the lights that may bring in happiness, prosperity, and healthy long life of the peoples of India and around the world.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युता शङ्करा प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा 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 मा सरस्वती शारदे मा सरस्वती शारदे पूर्ण इस अज्ञान उदति से पूर्ण इस अज्ञान उदति से वीणावाणी तार दे तार दे तार दे माँ सरस्वती शारदे माँ सरस्वती शारदे सूर्य ब्रह्म शिव विष्णु गजानन जिन चरणों को सेवते आ सूर्य ब्रह्म शिव विष्णु गजानन जिन चरणों को सेवते हम शिशु है अज्ञानी माता इन चरणों का प्यार दे वीणा वाणी तार दे तार दे तार दे माँ सरस्वती शारदे माँ सरस्वती शारदे पूर्ण इस अज्ञान उदति से पूर्ण इस अज्ञान उदति से वीणा वाणी तार दे तार दे तार दे माँ सरस्वती शारदे माँ सरस्वती शारदे
Thank you. Now, moving forward, I would like to invite our honorable dignitaries on the dais. So, ladies and gentlemen, please welcome our chief guest of the conference, Dr. Mayank Dwivedi sir, Director, DMSRD, DRDO Kanpur. May I request our guest of honor, Dr. Suhas C. Saha, sir, Roti Sydney, to kindly please come and grace us with your presence on the stage, sir. May I request Professor K.N. Pandey, Head Mechanical Engineering Department and General Chair, IMME 2022, Professor A.K. Dubey, Conference Chair, IMME 2022, and Dr. Manish Gupta, Sir, Organizing Secretary, IMME 2022, to kindly grace us with your presence on the stage. Ladies and gentlemen, let's have a huge round of applause for the esteemed dignitary sit here on the dais. Now it's time for the bouquet presentation of our esteemed dignitaries. In Indian culture, that Atithi Devo Bhava, that tradition of India, it reflects. I would like to request Professor H.S. Goyal sir to present the flower of our chief guest, Dr. Mayank Dwivedi sir. Professor H.S. Goyal sir. Sir, please. Thank you very much, sir. Now I'd like to request Professor Mukul Shukla sir to present the flower of our guest of honor, Dr. Suhas C. Saha. Professor Mukul Shukla sir. Thank you very much, sir. Ladies and gentlemen, let's begin. Now I would like to request Professor A.K. Dubey sir, Conference Chair, IMME 2022, to kindly come forward for his welcome address. Professor A.K. Dubey sir, please.
Thank you, Dr. Tej Pratap. Honorable Chief Guest of today's function, Director, Defense Materials Research Organization, Kanpur. Guest of Honor, Dr. Swasi Sahaj, University of Technology, Sydney, Australia. General Chair of the Conference and Head of Mechanical Engineering Department, Professor K.N. Pandey ji. Our members of organizing team, Organizing Secretary, Dr. Manish Gupta ji, Joint Secretary, Dr. Tej Pratap ji, our faculty colleagues, invited guests, participants from different parts of the world, physically present here and connected online via YouTube, students, ladies and gentlemen. A very good morning, Suprabhat and Namaskar. On behalf of organizing committee and my own behalf, I welcome you all in the inaugural function of this international conference on innovations on mechanical and materials engineering. I feel honored and privileged to welcome our chief guest, Dr. Mayank Dwivedi ji, and guest of honor, Dr. Suhasi Saha ji, who are well-known figure and have significantly contributed in the field of mechanical and materials engineering research. We are really honored, sir, by your benign presence here. Our director, Professor R.S. Sharma could not attend this inaugural function due to very urgent assignment. He has always extended all type of support to organize such type of events which are helping in advancement of science and technology. As you can see, the theme of conference is mechanical and materials engineering. Many of you present here may debate that why mechanical materials engineering. Why don't we say only mechanical engineering? Because all of we are aware that sustainability of mechanical engineering is always questionable without selection of suitable kind of material. So like Sita Ram. So the weightage of this Sita Ram word in combined has more weightage as compared to only Ram or Sita. So materials are indispensable part of the mechanical engineering. That's why, keeping in the mind the theme of conference, a title of the conference has been kept as Mechanical and Materials Engineer. In this 2 days conference, we are going to discuss about all aspects of mechanical and materials engineering under 4 themes of the conference, namely materials and design, manufacturing engineering, industrial management and automation, energy and environment. Whatever be the form of technology, whatever be the field of engineering, we are nowadays debating on sustainable development. And in sustainable development, we are mainly focusing on energy efficient processes and environmental aspects. Unfortunately, we are debating much, but working less. What happens with device, product, processes, and systems as per our requirements? In this materialistic world, there are number of factors which are defining our requirements. And when we are devising, we are not considering the energy efficiency or environmental aspects. What happens when the losses become to the alarming situations? When it comes to the alarming situation, then we wake up and try to make up. This is not our Indian concept. If you see the civilization of India and culture of India, we are very much concerned from very beginning. So we have to take care from conceptualization stage itself, efficiency of energy and environmental aspects. See what happens. I am quoting a sloka of our Indian literature. यो देवो अग्नौ यो अप्सु यो विश्वम भुवनम आविवेश य ओखदेशु वनस्पतिषु तस्मै देवाय नमो नमः. So in the very beginning we have focused on the natural resources and natures. When we give status of God to anything, we take extreme care of that thing. So this is the time, this is the hour to accept this concept. As per our call of papers, authors from different parts of the world have contributed more than 300 papers after preliminary review at editorial stage itself. 225 research papers have been paused for peer review. And after peer review and rejection, 137 papers were accepted for oral or poster presentation. In this conference, total 141 participants are registered from different parts of the world. And they are going to discuss theoretical and practical aspects of the conference themes in this 2 days conference. And it will also be beneficial for our participants that some keynote lectures have been planned by eminent speakers. 2 keynote speakers are present here in this function. One keynote speaker, Dr. M.V. Reddy from Canada, will join online after this inaugural session. You know, the main objective of such kind of gathering is to discuss about advancement of science and technology, especially based on our conference theme. But aim is always to benefit the society, benefit the mankind. So let us start this conference with the objective. It is not unknown for us, it is very well known for us. That is Sarve Bhavantu Sukhina, Sarve Santu Niramaya, Sarve Bhadrani Pasyantu, Ma Kaschid Dukbhag Bhave. So whatever be the outcome of this today's program, that will always be beneficial for mankind and society. And once again, I welcome you all for your benign presence here and also being connected online in this function. Thank you.
Thank you, sir, for your golden words and relating the mechanical and materials aspect, which is really beneficial for us and life problems. Now, moving forward, I would like to request Professor Kane Pandey, sir, General Chair, IMME 2022, to kindly come forward and address to the audience. Professor Kane Pandey.
Good morning and thank you, Dr. Tej. Chief guest, Dr. Mayank Dwivedi ji, Director, DMSRD, Kanpur. Honorable Guest of Honor, Dr. Suhasi Saha of University of Technology, Sydney, Australia. Professor E.K. Dubey, Conference Chair, Dr. Manish Gupta, Organizing Secretary of the Conference, Heads, Deans, faculty members, and participants joining this conference in physical and online mode. I welcome you all in this pious city of Prayagraj, which is the Sangam of Ganga, Jamuna, and Saraswati. This Department of Mechanical Engineering is one of the oldest departments of the institute, which is started in 1961. The department is having qualified and experienced faculty, 35 faculty members in all streams of the mechanical engineering. It has 55 research scholars in the institute stipendary category. The department offers 2 undergraduate programs, the BTech in Mechanical Engineering and BTech in Production and Industrial Engineering, and it has 5 MTech programs. Those programs are design engineering, production engineering, thermal engineering, computer design and manufacturing, product design and development. As far as the theme of the conference is concerned, it is based on the basic need of innovation, which plays a key role in including novelty in the existing products, processes, and the and the services, which increases the market share, revenue, and customer satisfaction. Now you see that today's work is very challenging and demanding. Sustaining without innovative products, without innovative thinking is not possible. We have to give solution to the society, and those solutions are for the challenging problems. Today we are moving from fossil fuels to the alternative fuels. We are moving from IC engine driven vehicles to the electric vehicles. And if we see the automobile, it is not only the mechanical device, it is very much a device consisting of sensors and others based on electronics and computer engineering. So the thing is becoming very, very interdisciplinary. So without innovative thinking, it is not possible to exist in the present world. So we have to think about the innovative things. And you see how the innovative things can be made by innovative minds. Like we are trying to harness solar energy. Harnessing solar energy with efficiency is the main problem nowadays. So we have to think about a material which can absorb more and more solar energy and which can convert solar energy into other form. Similarly, if we go for the defense, we have to make, or the people are making materials which can be coated on the fighter jets, which can disguise the radars. We are going to make materials which can be used in turbines, which can work at very high temperature. If we go for the nickel-based alloys, they have moved from CMSX1 to CMSX10, and that is possible only for innovative thinking and the work done by our scientists and the engineers. Similarly, the other areas are like the alternative fuel. In the alternative fuel, we are blending ethanol and others in the petrol and diesel. Now we have to think about some other out of the box things, and that can be done only by the innovative thinking, like the organic waste. We can convert organic waste into methane, and that methane can be blended. People are doing this. The CAD, if you see the CAD was started from computer design, but now it is helping in the additive manufacturing. Additive manufacturing is opening a new era for the mechanical engineers. And the mechanical engineering, if you see, is a very old discipline in which there is only a foundry, and like that is not. It is going into digitalization, the AI, artificial intelligence, Internet of Things. These all are making it digital mechanical engineering. Digital twin is one of the things. And so we have to think not only in the mechanical way, but in a digital way. Now the world is the digital. And it is there. If you see the basic thing which we usually day to day use, that is our vehicle. This vehicle consists of the interdisciplinary involvement of the technology. the automation and smart system, making the industry automated, making it smart is one of the challenging area. Now, if I talk about the material, then materials are developed by either metallurgists or the material developing persons. They are just like a chef. Like a chef uses different spices and makes different recipes. In a similar way, a metallurgist or a people working in the material science and the materials development of material, they just use different alloys, different other combination to make a newer material. So they are safe in our engineering environment, and it is very important for them to develop a newer material. Newer materials are being developed. So I will not take too much time. Once again, I am very much thankful to our chief guest and the guest of honor and the other dignitaries in the on the dais and in the hall. Thank you.
Thank you, sir, for your keywords and highlighting the innovative idea, importance of innovative minds, and how to correlate the cost-effective solution for such things. So, with your keywords, the innovative minds और कहते हैं जैसे जागृत अवस्था और अपने अंदर के रिसर्चर्स को जगाना, a small paragraphs I remember, कहते हैं तोड़ना है हर पिंजरा, मेरी उड़ान अभी बाकी है, मंजिलें जमी भर नहीं, आसमान अभी बाकी है, लहरों का थमना नहीं, समंदर की बेबसी, बाहर खामोशी सही, भीतर अभी तूफान, कई तूफान बाकी है. मीन्स अपने अंदर के हमेशा इनोवेटिव माइंड्स को जगाते रहिए और नए रिसर्च से समाज की सेवा करते रहें. Now moving forward, I would like to request our guest of honor, Dr. Suhas C. Saha sir, to kindly come forward to address the audience. Dr. Suhas Saha sir.
Respected chief guest, Dr. Dwivedi, the director is not here. The head mechanical engineering department, Professor Pandey, the conference secretary, Dr. Gupta, faculty members, research scholars, participants and students, Namaste in Hindi, Namaskar in Bengali, and good morning to all. So I'm very delighted to be present in the innovation in mechanical and material engineering conference, organized by Mechanical Engineering Department. So we have recently overcome the biggest threat of the century for the civilization, COVID-19, where exchange visits and programs like conferences, the workshops, the seminars could not take place. And I'm also a victim of that. I should visit this in early 2020, but due to COVID, I could not come to India. I believe the similar threats also exist in our profession. Mechanical engineering is recently experiencing a rapid transformation owing to artificial intelligence, as Professor already mentioned, and also machine learning, the virtual reality, the microgravity condition, environment, to name a few. So I can recall when I start my research in 1998 in CFD, computational fluid dynamics. We started using boundary layer equations. It's a very simplified Navier-Stokes equation, and we solve analytically and sometimes numerically. And it's a very simple equation, and we use only a single processor. And then the modification came up after that. And then we came from boundary layer to a two-dimensional rectangular or square cavity like that. And then we moved to the three-dimension. Okay. And now this CFD computational fluid dynamics is used everywhere. Even we can solve this airflow or heat transfer into this whole building because we have the capacity, the computational capacity. So it is changing. The technology is changing a lot. So recently we are applying our CFD, our computational fluid dynamics knowledge in biomedical engineering field, like our heart, our lung, our brain. So we are applying this technique. So what happened recently? We are taking the CT scan image of our lung, and then from the CT scan we are creating the three-dimensional the lung trees. We call it trees, a lot of branches, and then we are actually simulating using computer. But the problem is, it is a very expensive computationally. And when we introduce some particles, like every day we are inhaling a lot of like ultrafine particles from environment. So we cannot introduce a lot of particles. I mean, we cannot introduce realistic number of particles. We use like 1,000 particles or something, but still we need maybe hundreds of or 50 processors to solve that problem. So what we have done recently is we use the artificial intelligence or the machine learning concept. So we are training this software with these 500 or 1,000 particles, and now we can use millions and millions of particles. So this kind of transformation is happening, and we have to, if we want to survive, we have to actually work on it. For example, before what we did is material science, they were doing APM, finite element method. And for CFD, fluid mechanics, they are using CFD. Now we are doing together. So they are merging now because we are doing FSI, the fluid structure interaction. Because the single one is not possible. Because when there is only material, there are some fluid. When there is a fluid, there is some structure. We need to combine all together. So we are combining these two subjects. So that means it's a lot of interdisciplinary study we have to do now. So we have to actually train our graduate as well. So we are doing a lot of, we are actually transforming our syllabus as well. So in ETS, what we are doing recently is we are doing like two types of syllabus for undergraduate students. So one is we are introducing the research in the teaching. For example, we are giving some assignment. The assignments actually focus on research as well. Also, we are doing some studio-based learning. Studio-based learning means there is no like a formal teaching what we do here, like a lecture and the students are listening. It doesn't work. What we are doing is students are sitting in a round table. They are working. We are giving them some project without telling them anything. So they are using their own innovation technique to solve one problem. So this is the things we have to do it if we want to survive. All right. So if you want to survive in this challenging scenario, the innovation is must. So I hope this conference will serve as a platform to focus on this innovation, and I wish a grand success of this conference. Thank you very much.
Thank you, sir, for your keywords and highlighting the importance of mechanical engineering and application of mechanical engineering in interdisciplinary and biomedical applications. From this stage, we assure you that, sir, that Mechanical Engineering Society will work for this innovative solutions and real-life biomedical problems like droplet dynamics, preparation of new materials, hydrophobic surface, which is very much important in COVID-19 scenario, and all those things, AI and CT scanning based analysis. Now, I'd like to request our chief guest, Dr. Menk Dwivedi, sir, Director, DMSRD, Kanpur, to kindly come forward to address the audience. Sir, please.
Professor K.N. Pandey, Dr. Saab from Australia, Professor Dubey, all the respected faculty sitting over here, delegates, students, ladies and gentlemen, very good morning to you all. First of all, I will thank Professor Pandey and his entire team for giving me the opportunity to come over here and interact with this August gathering and share my experiences of developments in defense, because I'm a material scientist and I spent almost 34 years. Primarily started my career with DST, Department of Science and Technology, 3.5 years I worked there, and then I joined DRDO. Also, it was great honor and prestige bestowed on me that I have been invited to this prestigious institute when I used to be a student. And as a matter of fact, I studied in Delhi College of Engineering and IIT Delhi. Then that time we used to call it MNR, and it used to be a very famous place. And every student's dream used to be that if we are not able to get into IIT Kanpur, at least MNR, we should get the next best choice, then Roorkee, and then used to go SBTI. So this, I just wanted to share a few words. Though I have taken over DMSRD Kanpur very recently, it was very difficult for me to come over in spare time because there are so many issues I have to resolve there. But once it came that MNR, that MNNIT Allahabad is inviting me, then I took the decision, yes, I will go there and share my experience. As a matter of fact, materials and mechanical engineering, they are complementary to each other, as Abjit has been told. And metals are so important that our societies were known by the name of materials, like earlier stone age, then bronze age, then iron age, so on, then silicon age came, then nano age came. And presently, I think the amalgamation of artificial intelligence, that information technology, probably in future molecular engineering and atomic engineering will come in picture. And that's how the complete transformation is taking place. As far as mechanical engineering part is concerned, let me tell you, I used to work very closely. I started my career with missile system, Prithvi, then Trishul, then Agni. Finally, 9 years I was in Barhun missile system. And I observed that finally the conventional mechanical engineering is getting over and over, in the sense reaching to the saturation level. This was when Professor K.N. Pandey and me we were discussing in guest room. That time also the discussion was going on. And now the time is there how to bring the innovation in the mechanical engineering, like mechatronics has been brought in, and how to bring the artificial intelligence, etc. inside. That's how we can make the mechanical engineering more versatile. Let me tell you, the maximum number of mechanical engineering products, if anybody has worked in India, I can proudly say we are DRDO people, we have worked. That will be missile launchers, let it be bridging system, state-of-the-art bridging system like modular bridges. The project director was Mr. Naresh Kumar, who is alumni of the same institute from Civil Engineering Department. Then talk about various other that ship-based stabilization system, etc. Anything, the radars, we are making the complete radar system, that entire assembly, the entire mechanical structure. We have done quite enough, and we have inducted all those products into Indian Armed Forces. They are worth about 2.5 lakh crores in Indian currency. But finally, we have found those mechanical engineering aspects, those mechanical engineering practices, now they are becoming obsolete day by day. Finally, we find when we talk about the launcher for the missile system, there used to be a launcher which used to be lifted by hydraulic mechanism. Then launcher used to perform completely as per the mechanical theories and all. But today we are talking about the EM railguns, where we want the electromagnetically simulated launchers are there, and where the launching velocity imparted to the missile system that almost overcome the booster phase of the missile system. Similarly, when we talk about the various other high energy materials, etc., the material research has gone quite high. But whereas we are finding the mechanical engineering, until we are bringing in the newer concepts, newer things, we are finding it is reaching to the saturation. Here, DRDO as a whole, we are working very hard towards that, because we understand if we make any system by imparting electronics, etc., it becomes a smart system. But the moment you impart the artificial intelligence, it becomes the intelligent system. The difference between smart and intelligent system, all of you know quite well. But even though for your refreshment of the knowledge, I will tell you the smart system are games where they tell about their health, how are they? But the moment they are able to heal themselves based on their environment, then they call intelligence system. And nowadays, the world is moving towards unmanned and smart systems. When I talk about the defense technologies, we are also moving towards that. I won't be surprised after 10 to 15 years there will be no manned warfare. I will not be surprised after 10 to 15 years there will be no war with tanks, ships, aircrafts, submarines, etc. Today, we have got certain technologies. We have from the satellite itself, I can detect the submarine 300 to 500 meters below the sea surface, and I can precisely kill the submarine. If such type of technology or sensors are available, then where are we going? We are going for the unmanned system and the AI, etc. What earlier speakers have spoken is going to be very important thing. Other thing I would like to tell you one more important thing, where at least about India, I can say we have to really work hard. Many times the things come up, we talk about, we give the presentation, we discuss big things, but finally on the ground, we are not able to materialize those things in terms of products. Nanotechnology, the word started in 2001 and 2002, and we were talking about big things. Even as a matter of fact, 10 to 12 papers on various nanomaterials and nanotechnology, I myself have published in international journals. But when we talk about what we have got tangible out of nanotechnology, where the society got benefited, where defense got benefited, where various other organizations got benefited, the country as a whole got benefited. There are very few things. Again, when we talk about those products, they are hardly limited to either DRDO, ISRO, and to some extent BARC. I think it is our collective duty. Whenever such buzzwords they are emanating from abroad or Western countries, we have got the enough knowledge, information, and capabilities. Let me tell you, there is no lack of capabilities. But we are not able to attack those things. I think there, as a faculty, as researchers, we in DRDO, industries, we have to join together, we have to collaborate together with a vision that we have to fructify those technologies for the benefit of the society. This this issue is really important issue, and during my keynote address, I'm going to elaborate on those issues further. And as far as materials are concerned, I am very happy that in India, a lot of research has taken place. And in materials, I tell you, India has done quite well. If you talk about the rare earth materials, then rare earth materials, India has done quite well. The rare earth magnets, we are doing quite well. Recently, I was co-chairing a session with ISRO chairman. At that time, also, he was telling me, Mayank, very soon we are going to develop rare earth free magnets. Because magnets are going to be very important for our electric vehicles. And the magnets is a big challenge because primarily today, for the entire year, we are dependent on China. And you will be surprised to know, except a few things for the magnet like cobalt, to some extent samarium, every rare earth is in plenty in India. But probably there we have to look into our policies so that we can mine them better and we can do better. Similarly, the A-class steel, B-class steel for the ships and submarines, DMR will develop. Talk about the bulletproof jackets. I can proudly say the bulletproof jacket, the type of materials we develop, the type of technology we in Demasadi develop. It is the best bulletproof jacket. Even foreigners, they say they want the bulletproof jacket developed by DRDO. Like that, like JP-10 fuel for the rockets, etc. Many things have been developed. But many a times we are not developed various very important alloys. And when we talk to SAIL and other Jindal Steel, etc., they say the requirement is so less, then we are not able to produce it because hardly our requirement is 500 kg or say 1 ton or 2 tons, maybe say maximum 10 tons. But 10 tons will not make any industry survive. So I think we have to look inwards about our export policies, etc. also, so that we provide them enough opportunity and cost benefit. Until they support your industry, they will not be able to sustain in the market because the cost competitiveness is so high with the foreigners that is very different. I will not take much time because it is an inaugural session. In 1 or 2 minutes, I will finish it off. I have seen the cases where we have developed a very important electronic device. I will not name it, but okay, we can say it's a very important control and guidance device, which was being imported by one foreign country. We were importing that device for 25 lakhs rupees each piece. The moment we started developing the technology, the country reduced the price to 15 lakhs. The day I transferred the technology of that device to one industry in India, they brought the prices to 8 lakhs. Now you understand, once you develop your capabilities, you are going to benefit your country to that great extent. The 25 lakhs worth of item was being sold in India for 8 lakhs rupees by same foreign country, and out of that 8 lakhs also they are running some profit. Nobody is giving from their pockets. So the point is, these are the things that are very important when our Honorable Prime Minister says that Atmanirbhar Bharat and ban on the import, etc., so many things. They have a lot of meaning. Basically, once you start developing your capabilities and technologies, then automatically you will find not only for the innovation, you gain you get better products. Rather, life cycle support and cost effectiveness becomes very high. So, with those words, I will just thank you very much for patience listening. During my keynote address, probably we can elaborate more, and if some questions are there, I will be very happy to answer it. Thank you very much. I wish this conference a grand success. Probably after lunch, I will not be available. I will be going away back to Kanpur. But after meeting the faculty over here, just now I was talking to Professor Garg also. So I think it's a very good institute, and it's my first visit. And if God willing, then I will keep on interacting with the institute, and we can work together in the collaboration for our future endeavors. Thank you very much. Jai Hind.
Thank you, sir, for your keywords and highlighting the importance of materials and nanotechnology or nanomaterials in the performance enhancement of the materials. I would like to request all the honorable dignitaries to please release the conference venue and announce the conference to be open. So now I would like to request Professor K. N. Pandey sir to facilitate our chief guest Dr. Mayank Dwivedi with Memento and Solve.
साथ में दोनों भी
Thank you very much, sir. Now I would like to request Professor A.K. Dubey sir to facilitate our guest of honor, Dr. Subhash Saha sir, with Memento and Solve. Thank you very much, sir. Without any delay, now I would like to request Dr. Manish Gupta sir, Organizing Secretary IMME 2022, to present word of thanks for communities.
Thank you, Mr. Prithika. Honorable Chief Guest, Dr. Mayank Dwivedi, sir, Director, Musabi Kanpur, distinguished guest of honor, Dr. S.C. Sasa, University of Technology, Sydney, Professor K. Pandey, sir, Head of Department, Mechanical Engineering and General Chair of IMME 2022, Professor Akil Bedi, Conference Chair, IMME 2022, Professor L.K. Mishra, sir, Dean Academics, participants from industry, academic institutions, and research organizations, members from press and media, respected faculty members, my dear students, all the members of the organizing committee, ladies and gentlemen, a very good morning to all of you. I, Dr. Manish Gupta, Organizing Secretary of IMME 2022, feel really honored and privileged to get an opportunity to propose our vote of thanks on this occasion. At the outset, I take this opportunity to extend a very warm welcome to one and all present in the International Conference on Innovations in Mechanical and Materials Engineering 2022, organized by the Department of Mechanical Engineering, MNIT Allahabad. I take this opportunity to place on record my hearty thanks to all the conference chairs, members of organizing team, and student volunteers for their enormous cooperation towards the organization of this event. I expressed my deeply thanks to our director, sir, who is not physically present here due to his personal engagements, for his time-to-time support and guidance, and for extending all the required facilities to us. I am also thankful to the Institute administration for their support. I am thankful to our sponsors, DRDO, Ultratech Cement, and NTPC. I would like to mention here that the department is having a very long association with the DRDO. In the past, when we didn't have adequate research infrastructure in the department, many of our faculty members completed their PhD work by conducting the experimental part of their research work in the different laboratories of DRDO. This time also, when we planned this event, we approached DRDO for help, and it really agreed. Sir, on the behalf of the department, I express my sincere thanks and gratitude for all the support you have extended. I am heartily thankful to our keynote speakers, Dr. Mayank Dwivedi sir, Dr. Subhash C. Saha, Dr. M.V. Reddy from New Graphite World, Canada, for their valuable presence in this international conference in offline and online mode. And I extend my thanks to all the eminent scientists from research organizations and also the faculty members and research scholars from various IIMs, IITs, NITs, various other universities and institutions for their participation and presence. I believe that the presence of such illustrious persons and participation of all of you will surely provide us a platform for the exchange of knowledge, ideas, and acquaintance with emerging areas of research. I extend my best wishes to all of you. I'll stop here with these words. There is an end to everything. There is an end to everything, but we believe that there is never an end, but always a beginning. Thank you. Jai Hind, Jai Bharat.
Thank you, sir. Ladies and gentlemen, now I would like to request all the members to please stand up for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाए तब जय गाथा। जन गण मंगल नायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
So now we are moving forward for our first keynote lecture of the International Conference IMME 2022. So our first keynote session on advanced materials and technology is given by our honorable chief guest, Dr. Mayank Dwivedi. Sir. So Dr. Mayank Dwivedi, Scientist G, is appointed as Director, Defense Materials and Store Research and Development Establishment. He is ME in Polymer Technology from DCE Delhi and PhD in Advanced Composite from IIT Delhi. He is the recipient of Gold Medal in ME. He is alumni of prestigious National Defense College, New Delhi. In his previous appointment, he was Directorate of Industry Interface and Technology Management for more than 5 years, and prior to it, he was Director, Defense Technology Commission DTC, Secretary for 2 years. He has started his career from CPDC ASN, Hyderabad in 1992. During his initial year, he worked in the area of polymeric composite and nanocomposites. He has worked in the area of stealth and radar absorbing system. He has worked on major projects such as Agni missile, BrahMos missile, warhead technology, and biomedical devices. He has an expertise in the area of processing and structure property relationship of advanced composites. He has number of international publications and patents to his credit. He has delivered many lectures in various international and national forums. He has authored 3 books on nanotechnology and polymeric composite. He is also a recipient of Agni Award for Excellence in Self-Reliance in 2018 and Lab Scientist of the Year Award in DRDO in 2003. Sir, please.
Thank you. Thank you for introduction. Again, Professor Pandey and all the distinguished faculty members, Dr. Saha, students, researchers, if media friends are there, media friends, ladies and gentlemen, very good morning to you again. नहीं अभी तो इसको ऐसे बैलेंस कोई फर्क नहीं पड़ता because I am not going to give any presentation. I am going to speak as the poor only. Yes. No PPT, nothing. Basically, as a matter of fact, I did not know that I have to deliver 2 addresses. So, had I known that, I would have brought that also, no issue. But I can communicate my message, whatever I want to say. So, it's good that just in 5 to 10 minutes again, I am back to you. And as long as you have the patience to listen to me, because they have given me 1 hour time, so I will ensure that I will not take 1 hour so that you are not feeling sleepy, etc. And before that, we break for tea and have some refreshment outside. Well, from where I left, I was talking about the materials and mechanical engineering, etc., and how the modern science and technology and the modern engineering practices are transforming the way we look at engineering practices, materials, etc. I will briefly tell you about DRDO also, but before I come to DRDO, one thing when I was about to talk about that, but because of paucity of time, I did not speak that. Now, because now I have been given time to speak, so I will try to cover that. There's a one thing called appropriate technology. When we talk about the technology development, etc., and all of you are the engineers sitting here, many a times we talk about the advanced technologies, the high technologies, cutting edge technologies, and our constructed mind is something like that. Whatever Western countries they do, it is the best thing. And when we talk about high end technologies, means it is something like once I remember I was sitting in a conference of prime minister. The meeting was there. The honorable prime minister was telling that many times I see that the people need items which is immediately launched in the Western countries. Probably that particular product, that particular technology may not be suitable to the country and may not be suitable to our environmental condition. But even though, like a kid, we always vie for that. As a matter of fact, let me tell you, when Bridgestone tires, they started supplying the car tires in India, the Michelin, none of those tires were successful in the country because they were meant for the different type of climatic condition, environmental condition, the road conditions are different, the temperatures are different. Those tires were too soft here. Why they had to change the complete formulation of rubber. Seeing the Indian condition, the tread has to be much thicker because the type of road, the type of potholes, etc., you encounter in India, probably those situations are not in Europe and America. And that's how that appropriation, the innovation was brought in. This issue not only has changed many aspects. When you talk about the defense technologies, I tell you the appropriate technologies, they have played major role because the type of systems what we are getting from abroad, many a time they are not able to work as it is in India. Many a time the hydraulic systems, when we deploy in the desert areas with our armed forces, we are finding it difficult. Then finally we have found that yes, many times the hydraulic system, the hydraulic mask may not be required because the type of gale, the type of high velocity wind along with the sand is flying, and there are those kind of particles are going into the piston and barrel mechanism and going into sometimes the hydraulic oil and creating problem. Many times you have to replace seals, etc. And once one system is stuck, then replenishing all the supplies, etc., and making it correct is a big issue. Then Indian industry they realize, Indian armed forces realize, the DRDO people realize, and we have tried now to replace most of the hydraulic system with the electrical drives. And we have found it is a better thing and a more successful thing. See, one thing I learned in my 34 years of career, one solution does not fit all. And many a times uh, in science and technology, with the advanced technologies, by some reason we have got this very fixed idea that yes, this is a new technology has come up and we have to do it. And I think this technology is going to transform the things. Like I told a few minutes back about the nanotechnology. Nanotechnology, let me tell you, we could not do much in India. As a matter of fact, let me give you one example of nanotechnology. Had I known that I'm going to deliver keynote address, I would have brought the video also. One experimentation was done with shear thickening fluids. Shear thickening fluids are the fluids with a sudden, at a certain shear, increase in the shear rate, immediately they become very hard solid mass and the viscosity goes infinite. But at the high shear rate, the viscosity goes infinite, and that's how they become a solid ball, and that's how they stop moving the bullet. This concept you may understand when you see the saturated mixture of sand and water. Then if you put the finger slowly inside, the finger goes in. The moment you try to punch, then your punch will stop. That is nothing but a sort of a dilatant behavior of the fluid. In the fluid mechanics, you must have read about it. And that's how the shear thickening fluid concept has evolved. One experiment was done by making the shear thickening fluid having the silica particle less than 50 nanometer size Some are dumbbell shaped, some are elliptical shape, and some were round shape. There was some ratio in the polyethylene glycol, and they made a putty sort of a shear thickening fluid. And when that fluid was applied just between two layers of nylon fabric, and nylon fabric I'm referring to what we use for our luggage, our suitcases, trolley, etc. It could stop, completely stop 9 bullet fired by carbine. This experiment was done. Some of our Indian institutes, they were also working with it, on it. And finally, it could not take shape to the extent where we could stop the bullets in future. This type of thing, when we try to deploy in the areas like Jaisalmer and all, then we found the shear thickening fluid because of polyethylene glycol. We were not able to sustain it because of high temperatures of 55 degrees Celsius. Then again, we reverted back to our old thing, ultra high molecular weight polyethylene fibers, Kevlar XP fiber, then various type of ceramic plates, etc. And that's how we found what is the right solution for Indian troops, and that's how we developed the bulletproof jacket. Although the nano fluid, that STF shear thickening fluid, has got many other examples for the blast effect, etc., etc. So many things happen. Somehow, in the materials, still a lot of research is going on, but primarily by the government institutions in India. I think still the one one view I am very much of that opinion. In India, the industry-led research I am talking about. I'm not talking about the development. When development, you talk about the system development and product development, industries are doing quite well. And recently, K9 Vajra gun has been made by IMT by itself in association with Hanova of South Korea, and that gun has been inducted into the armed forces. Very good thing they have done. And like that, many other industries, they are coming up with various systems. But when you talk about the subsystem level, when you talk about the component level, when you talk about materials level, where the pure SNT is required, still the Indian industries, even all the industries world over, they are dependent upon R&D institutions and academic institutions. And that's how, if you talk about the high energy materials, I remember pretty well when I joined the job, that time we used to talk about primarily three things: TNT, RDX, and HMX. And beyond HMX, we were not able to think. Late beta HMX came, where 6 micron particle size came, and we were thinking that HMX we have done everything. Now any bomb, anything we can make very successfully. Or our material business was going on very strong. Then slowly, Fox 7 came, then China Lake CL20 came, and we found the type of explosive we developed, the type of rocket propellant we developed in India, we became completely self-reliant. We have done various technology transfer for various explosives. Today, all of you will be surprised to know then I think most of the requirement of England, Germany, if I'm not wrong, France and USA also, is being catered by Indian industries. Our shiploads of RDX, HMX, etc., all the explosives are being exported. And the company is in Nagpur, EEL, Economic Explosives Limited. They are doing this. Here with this, I will also like to tell you, during this surge of development of materials and engineering systems, various industries they started with institutions like DRDO, ISRO, BAR, and primarily DRDO, because DRDO being the defense R&D organization, we were having the captive customer, Indian Armed Forces, and whatever we used to develop like missile system, we talk about the Agni, Prithvi, Akash missile system, Brahmos missile system, Prahar missile systems, and all other missile systems like Helena, Nag, everything got the customer, and that's how the money was being funded to DRDO in a large number. And that's how the industries were associated with us and we were developing it. And in this course, industries develop their own capabilities also. I will like to tell you If you talk about the Apache missile system, which is one of the best anti-air missile system, we were working with 256 industries. If you talk about the ATACs, artillery towed gun system, towed artillery gun system, advanced artillery towed gun system, where when the Honorable Prime Minister told, after 75 years, we have heard this voice, heard this gun. That was ATACs only designed and developed by DRDO along with Bharat Forge and Tata Advanced Systems. In ATACs, there are 464 industries working with DRDO. Then what happens when this type of construct is there where the industries are participating in such a big way? It is not only that they are getting a supply order, they are getting that financial support, and they are getting the companies coming up where also their capabilities are being enhanced because they are my own industries, they are Indian industries. So I do not give only know how, I give them know why also. And I give them complete design knowledge also so that they can develop the further variants also. So that DRDO can move over to other newer systems. Today, most of the industries in India, they have come up so well and they have become a very important partner in the supply chain, global supply chain, just because they work with the institutions like organizations like DRDO, ISRO, and BAR. And today their capabilities have been enhanced so much that they are supplying components and subsystems to the industries like Lockheed Martin, Boeing, Sejam, Thales, like it's Airbus, so many people. What I want to tell you, until unless we talk about the inclusive growth in science and technology, we talk about inclusive growth for the materials, for the engineering systems, I think it is not possible to leapfrog in the technologies. As a matter of fact, these industries, their capabilities, they are being harnessed by us only. And that's how those industries, those institutions are supporting us. Suppose the TRL level of any technology what I want to develop is initially 2. I engage in institutions like MNR that I ask them, yes, you please be the partner, you develop this certain technology, you please certain some test protocols, etc. And you tell me what is the science and engineering behind it. And based on your input, I will develop further technology. That's how today, if you see DRDO, for the development of materials, for development of various component and technology level ideas, we have funded almost all important institutions, academic institutions in India, and today our funding to the institution is to 2,000 crores, where we are also funding the institution as Center of Excellence. Recently, the latest on what we have funded is IIT Delhi, where our funding has gone up to 500 crores. I think now we are going for the 13 COEs all over the country, where various institutes, etc., are there. And I have found whatever the technology for that funding I have given to one academic institute, that institute has come up so well in that they bought some equipment etc. out of it. Then when next time I went to them, they were talking about much higher level of technology development. And that is the extent, that's how we are developing the complete ecosystem for the science and engineering. When I am speaking all these things, it's my duty also to tell you about DRDO also, so that you can appreciate that how do we go about it. DRDO is an organization where there are 47 laboratories, and these 47 laboratories are divided in 7 clusters. These clusters are: number 1, missiles and strategic system; number 2 is the aeronautical system; then naval systems and materials; then life sciences; then we have got armament and combat vehicles; then we have got MCC, that microelectronics and computational devices; and then we have got life science, aeronautics, naval systems, armaments, and related technologies. Like that, we have and electronics and communication. Like that, we have got the 7 clusters. In these 7 clusters, there are all the 47 labs are divided. Like my lab is a DMSRD, and I am a materials and stores research and development establishment. So I come under the cluster called Naval Systems and Material Science. So that I am doing it. And DRDO has got one very good idea that whenever any project we launch, for the development of the technology, we right from the beginning involve academic institutes. That's how when the TRL levels are low for the technology, then academic institutes are involved. Then we also involve the industries right from the beginning, so that as the technologies are getting developed and we are going for the system design and system engineering, then industries are right for the beginning partner. And the time we reach the TRL level 5 or 6, that time we go for the prototype development, what we call technology demonstration project. Once the TD is done, then we offer the Indian Armed Forces, my technology is ready. Now I want to go for the mission mode program. At that time, we launch a product with the industry. At that time, we transfer the technology also, it goes into the production. At that time, TRL level is 7 and above 8 or 9, you can say. This entire process, when closely examined, we find it is a fantastic ecosystem. We have a win-win situation for everybody. During this entire process, from SNT, from academic institutions, to the level when we reach for the production of the system, Indian academic institutes are given enough resources. They develop themselves. They develop the infrastructure. The good quality of students are turned out. They get better exposure. Finally, they become the manpower asset for further science and technology. The industries, not only the primary or major industries are engaged, they are tier 1 industries like Tata, L&T, or Godrej, or Bharat Foods, or Adani, etc. But along with them, the tier 2 and tier 3 industries are there. They also get involved right from the beginning at the component level and materials level. And let me tell you, none of those industries they get engaged with us while looking for the major program. They are never left in lurch. If industry is not quality-wise competitive or cost-wise competitive, then only the industry might be changed. Otherwise, the industry is with us. We nurture it properly. And that's how today I can proudly say in the DRDO ecosystem, more than 14,000 industries work, where 2,100 industries are, which are tier 1 or tier 2 industries. So these type of systems have been evolved. And what happens when we are developing the technology, it's not that the final product will be made, only then the technology will be transferred. During the entire development process, there is final development, and at various levels, various technologies are being developed. Like we talk about the missile systems. Like talk about the missile system called Helena or non-missile system. While we are developing the missile, we are developing the ability miner technology. We are developing IOR seeker technology. We are developing control and guidance, fire and forget systems, launcher system, various stabilization system. Whatever these technology we are developing, we are inviting the industry, please come and take these technologies. Because many what happens, the ingenuity of the industry also we cannot underestimate. Many times I have seen they have taken some technology from us, and the type of exploitation they have made out of this technology, they could get very good export market. So we do not want to bind our industries by anything. And that's how now we have also done one very good thing, because we have found so many materials, etc. we have done, so many research we have done. Like I tell you about the DMRL and DMSRD, NMRL, they are 3 major materials lab. So many patents we have got. Now we have made a policy that any Indian industry which comes to us, our patent will be provided to them free of cost. And now we have started doing this. Now we have got more than 450 patents which can be shared, and those patents we are sharing with the industry free of cost. And any technology industry develops using DRDO patents, we say it is your completely marketing right. You make a product, you make anything out of it, it is completely your marketing right. Anyway, patent is mine because it has been filed. So patent will remain mine, but all the exclusive marketing rights are given to you for the new technology development. Such type of things, they have really helped that further exploitation of science and engineering. And here, let me tell you one very good example I will cite. When we do these type of transfer of technologies, like there's a one system is called Pinaka. You must have heard. That is unguided rocket system. That 12 rockets are fired in a barrage and tandem manner, and in a few seconds, any battlefield you can destroy completely because it is a some big warheads are there inside with explosives, and at a time 100, 200, and 500 rockets are fired at one target. That rocket system, we wanted to enhance the range. We enhanced the range to 60 kilometers. Armed forces told no, already you are giving 45-kilometer range, 60 kilometers is not good enough. I think we will go for 90 kilometers. We go, okay, we will do 90 kilometers. Meanwhile, the industry just took the transfer of technology. That industry told, sir, you people have given us complete technology, know how, know why. We understand the complete system. We know how to enhance the range. If you permit us, we will go ahead. Maybe yes, you are permitted because you are my industry. I don't want to hold anything. If you want to do, you do it. They invested their money. And after investing their money, they made the rocket, which was 90 kilometer plus. They tested and tried out and find that rocket completely developed by that private industry has been inducted into the armed forces with minimal hand holding by DRD. One good thing is there, whenever see, as just now, when the vote of thanks were being given, that time it was told that most of the faculty members and most of the students, they have carried out some experimental work in DRDO. We are quite open to it and we always encourage. Similarly, when our industries are working with us, we also encourage for any development. If industry is stuck anywhere, we handhold for our technologies. Even now, we have made a new policy. If industry wants to develop some new product or system, and they are stuck in the want of certain technologies because Indian industries, not like the Western countries, they have got a big research departments. Probably India is still being a developed country; they cannot afford because the cost of the research and development wing in any industry is quite a costly affair. Countries like America, France, etc., and England, Germany, they are able to afford. Today, you see Lockheed Martin, they have got a very strong research department and they are developing each and everything by themselves. Talk about the Rafael people, the saffron. The saffron people are making the engine. They are making the engine. Only 4 countries in the world they are making or manufacturing the engine, that jet engines. So because they have gone into that R&D thing, and initially the government funding was there, that's how they could do it. So similarly, what we do, we have developed a system in India also. In might be you can say limited way, but now we are going full throttle. If suppose some industry says this particular engineering system, they do not have any experience, they do not have any strength, then DRDO becomes a vendor. We say we will give you the quotation. This much money we will charge for development of this particular engineering system. If you want, accept it. We will deliver you complete know-how and technology. And whatever the foreground IPR is there, that is either yours or it is jointly by us. And let me tell you, we being the non-profit making organization, we are government funded organization. So whatever such type of activities we do not charge a single paisa profit. It is simply cost to cost basis we supply. And recently, one example I will give you. Some torpedoes were supplied to Myanmar Navy, and how to make the fire control system of the torpedo with the console of the ship to the torpedo which is at the belly of the ship. That software had to be developed. The complete hardware software the system was required to be developed. And the industry asked DRDO to develop the complete console and the software. We designed and developed it, supplied to the Indian industry, and the industry supplied to the Myanmar Navy. And that's how the complete export could be materialized. So those are the things already they are doing, and we understand one very important thing, and my request to all of you, specifically the students, until unless we support our private industries to the extent possible, Though it's an international conference, but I will talk about a little bit about India also. You cannot make the country India as a developed country because your development will be driven by the growth of the industries. They are the profit earner for the country. They are the revenue earner for the country. They have to be supported actively. I remember when I was scientist BNC and I was a young scientist of 22 or 23 years old. That time meeting the private industry used to be a big taboo. As if I will need private industry, there will be a big issue. I was very comfortable meeting with the ordnance sectors and public sectors. But today that construct in mind has changed because finally we have realized if really we want to go on the growth path, that has to be like that. See, today I talk about the A, B steel, we talk about the various type of ship materials, talk about the various ceramic materials for the bulletproof purpose, for bulletproofing of the vehicle, talk about the various type of underwater paints, what not, the various kind of explosive, etc. What I was telling about CI-20, HMX, RDS, etc. They were only possible because the industry were associated with us. Otherwise, how much we will make? A few kg, few hundred of kg, that will not meet the requirement of even Indian Armed Forces, forget about the exporting it. So that's how the Indian industries were brought in. And today I am proud to say this ecosystem is working so well, then things are moving in the right direction. Nevertheless, one more thing is important. Still, lot of exotic materials we need to develop. In India, let me tell you, many a times we have got the ideas, concept, designs, etc., everything in our mind. But to convert those ideas and concepts into the real tangible products, we do not have materials. Today, if you talk about all the technical textiles, they are not available in India. I am very happy that Reliance Group has declared they are going to make a big carbon fiber plant in Gujarat, and that is going to be the biggest carbon fiber plant in the world. I am very happy that this carbon fiber rose would be over. Similarly, you talk about any other exotic material like Kevlar fiber, which is aramid fiber, or talk about any other like silicon carbide fiber, or many other things like that. They are not available. Talk about the very special alloys, they are not available. Like I tell you, DMRL has developed DMR 1700 steel. Because of that, many of the breathing systems, etc., where the high stainless steel was required was possible. And we do not have certain technology. Still, we are primarily dependent on foreign source for various metal alloys. Probably sometimes we have got the technology with us, but because our requirements are so less, then economy of scales, they are not viable composition. So I think because this is a materials conference, I am not talking about the electronic system, etc. Otherwise, you talk about the ceramics, the phase shifters are required. How to make the electronic scanning radars? Those antennas are primarily all the synthetic materials. This construct whatever we had earlier in our mind, most of the things are possible with the metal and metallic alloys. I think so very fast they are being replaced by composites, many other things. As a matter of fact, the newer materials have changed everything. Once upon a time, we never heard about what to do with the niobium. But today, niobium is such an important material. If niobium is not there, your touch screen cannot be made. And today, you find that niobium is only in Afghanistan, in and around Afghanistan. Very little resources are available. And fortunately, unfortunately, only China holds those minerals. So finally, you are dependent on other countries. So now is a time that we have to think of making touch screen where we are free from niobium because the resources are very limited. Similarly, when we talk about the lithium ion battery, let me tell you, prior to lithium ion battery, lithium was hardly any material to be talked by anybody. It was hardly used for, if I'm not wrong, for some lubrication purpose, for heat resistant glasses, like the small applications were there. It was only laboratory skill curiosity and some small minor things. But today you find without lithium you cannot do anything. Similarly, the magnets, when we talk about, then we found this science is very important, the metals are very important. We find rare earths are playing important role. And this is by chance is our luck or bad luck you can say. And cobalt, which is a very important magnetic material, which is used for samarium cobalt magnets. Cobalt, not a single trace is there in India. It is God's design. So finally, cobalt, we have to be dependent. So these are the challenges they are in front of us, and how to overcome those challenges. This is a big thing. And let me tell you, we can discuss many things, many conferences, many new ideas. But until unless this materials thing is sorted out, let me tell you, nothing is possible. Talk about the electronics industry. We talk about there is no foundry. The fab is coming up with Taiwan. Some collaboration is going to take place very soon. But finally, when fab, etc., you are going to have here that silicon nitride you talk about, we use gallium arsenide, all those materials. We used to develop the complete, we used to make the wafer here. We used to grow the crystal, but the seed of the crystal, the nucleating point, that used to be imported from other countries. So I think until unless this self-reliance type of thing will come, then we are not able to attack the right things. And moreover, the materials. Materials are going to play a very, very important role because day by day, the materials are guiding your systems. I tell you, the innovation is taking place so fast. And primarily, if you see very closely, whatever new technology you are seeing, I can assure you, if you go through the papers and other things, you will find finally the new technology largely was dependent on the newer materials or the processing of the materials. Here, another thing where you researchers have to be very focused. In India, we find the processing technologies are also big challenge. Many times we have the material, but how to process them for the desired result? I tell you, it's a very big challenge. Basically, if I start talking about the processing technologies, I think it will take one more hour to discuss all those things. Huge challenges there. Still, with the materials, we are not able to process to the level where we need it. And I think this is another area where the machine design people have to work. As I told earlier in my lecture, the mechanical engineering is slowly and slowly getting saturated. When you talk about the structures, when you talk about the devices, but when you talk about the machines, using the mechatronics, using the electronics, smart features, intelligent features, AI, etc., is still in mechanical engineering, the machine design, the processing equipment, lot of scope is there. But those days are gone where I say I am a mechanical engineer and I know mechanical engineering so well and I alone can design and develop everything. No, it is so much interdisciplinary today. Until unless we interact with all, we cannot do it. That I need not tell you. But finally, applying that knowledge through some medium, then medium is the material. That is another thing. And there's, as Dr. Saha told about the COVID time that we were not having any conferences as trial, we were restricted and all. Basically, COVID time also taught us we have got that much resilience, we have that much understanding and that much capability that if even in a challenging time we want to do something, we can do it. Let me tell you, during COVID time also, the type of research and development has taken place in the area of biomedicines and devices. I tell you, phenomenal. About DRDO, I can tell you, not only 2DG drug came out, not only 2DG drug came out by DRDO, 18 industries took the transfer of technology. It is our luck that COVID is stopped. But whenever we had the trials of 2DG drug in our hospitals of DRDO, after giving first and second dose, the entire virus was gone. And I tell you why virus was gone, you will be asking me that what is the theory behind it, though I am not a doctor, but I give you simple theory. The 2-deoxyglucose was the thing, a material, a chemical which had been designed and developed long back by America, but that particular application can be used for killing the virus. That was rather discovered by DRD. And how we discovered it? Because that complete technology was not with us. Because the product patent was already with other country. So we developed the new process technology where the yield of the normal glucon D, the glucose, can be converted into 2DG, where the one oxygen from the glucose at a 2 position is removed. Then what happened when this glucose is given to the patient? Virus thinks that it is my food which has come and it tries to bite it and wants to eat it. But finally, virus finds it that this is not a proper glucose, and their glucose kills the virus because it is not a glucose. It is not a proper glucose because when oxygen is missing, it is not fulfilling the nutrient of the virus. That's why first and second dose after, all the virus in the body of the patient were killed. And that was a very successful medicine. It so happened in a large number, in a bulk, we could not supply to Indian market. And though technology was given to 18 people, but that was the ingenuity of the scientists. Even in a challenging time of the COVID, we did it. Not only this thing, even 47 or 48 technology were developed during that time with DRDO, with various academic institutes, and along with the industries. And that's how the entire COVID pandemic, I tell you, such a large country of 1.138 crore population was handled, and that was done. And of course, you all know the story that finally our Indian vaccine, etc., the co-vaccine did quite well, and finally people got benefited. So, lastly, I have already taken 40-45 minutes. Lastly, I will only say one thing. The conference, whatever we are having today here, it is a fantastic thing in the sense because it is all the relevant things are there and all the intellectuals are sitting there. The language what I am speaking and what you are understanding, I think we understand, correlate ourselves quite well. These are the facts and realities of life, and that these are the things which are the challenges in the science and technology. If we do not mitigate them with our collective efforts, it is very difficult. And let me tell you, we should be very open to the collaborations. We should be very open to the exchange of thoughts. I think it is not possible because it's my DRDO experience that one single agency and one single entity can find all the solutions. And that's how DRDO has understood that role of academia, industry, user, who spells out the requirement, they are very important. And if giving such type of collaborations, I think in future we will be talking about shared technical fluid in a big way, spider silk, and very other new exotic materials, various ceramics, fine ceramics, advanced ceramics, rare earth materials, rare earth magnets, rare earth free magnets. So many challenges are there. We will be able to do, of course, important metal alloys, which again we are finding a lot of challenges, and we will be able to do the justice to our engineering branch, and we will be able to make better products and systems in future, and we will be able to make our country self-reliant and moreover the entire world to be a happy family so that we can live peacefully together and we can do all the peacefully together and we can provide all the solace to the world with our newer technology and newer developments. Thank you very much. Jai Hind. Oh, well, great. If any question, kindly ask me. I will be very happy to reply you. Sir,
You were talking about the medicine not developed by the DRDO for COVID. Why that was not commercially available in the market easily? And that was
Now-
very popular also.
sir, now it is available. Dr. Reddy's lab and all the big labs, they are manufacturing it. But probably today demand is not there, that's why it's not available. But that time during the COVID time, let me tell you, lakhs of sachets were distributed all over the country. But requirement was so huge. Probably that small drop in the ocean could not be seen. Probably, I think we had we known the system of virus may come in future based on our some forecasts, etc. Probably that medicine would have been given as a TOT to various industries right from the beginning, and that would have been available in the market. But probably statistically, we did not plan that that medicine is required in that number, and the yield is very less, only 25%. So because of yield, whatever glucose we take and we convert it into 2 dg, the yield is 25%. We have to package it and supply it, and that entire transportation system, entire supply chain mechanism was collapsed during that time. You know it, complete curfew, or no trucks, no nothing was operating. But nevertheless, wherever was possible, all the government hospitals, etc., we could make it available. In a sense.
My question is, as all academic sector is working on the EV side, So what the DRDO is doing for the battery materials recycle and reuse and material heavy metals used in the PC.
DRDO in the EV things, they are primarily working on the magnets. Our area is the magnet. And as far as making the complete battery is concerned, already industry's capabilities are quite good. They can do it. Wherever industry required any handhold support by DRDO, we are providing that. And for the magnet, we are putting the special emphasis so that we can provide them magnets at a cheaper rate so that all these e-vehicle things can be sorted out. Second thing was the what about the environmental concerns and when the e-battery would be made. Basically, as I understand, the carbon footprint they generate and their disposal is much bigger challenge than whatever we are having the fossil fuel based vehicles. Towards that also the things are being worked out that what should be the mechanism whereby those things can be done. And there not only those materials to be pulverized and transformed into some composite material for the making roads, etc., many other requirements, etc. Even those magnets will be taken back. The technology are being developed. How to retrieve the rare earths again back from the used batteries, used magnets, and recycle them. All those issues, all those things are being taken care of, not only by DRDO, various other government agencies, and solutions are coming. Thank you. Okay.
Thank you, Dr. Divedi.
Sir.
I'm Mukul Shukla here in Mechanical. I was browsing through the EMSRD website and unfortunately we don't find the so bad. So we would look forward to interacting with you and possibly get into a formal engineering type of a thing. So although towards the end of the lecture, quickly summarize niche areas or possible scope of interaction and collaboration. I think Professor Pandey and our team would like to interact.
I would be very happy if you people can work with us for some special fuels. It is again mechanical engineering and chemical engineering combined work. We are making basically when rocket is fired. Initially, rocket is fired with some fuel. Right from the beginning, booster is not ignited. To ignite the booster, again some initiatives required, some fuels are required. There are smokeless fuels, and which are high density fuels. So those fuels, the idea is working. We have got a very good mechanism, and then we are developing one by one. But it is a very high end research, and there, if you can support in these fuels, then I think it is a one area. Apart from the various other composites and other nanomaterials are there where we can work together also. And I said, let me tell you, I tell you the strength of our institute is what because as I told, 34 years is I have completed in the job. I used to be the member in the campus selection committees. Used to go to various institutes to select the students for DRDO and BrahMos. The institutes like you have got a very strong footing in one way. You people still concentrate on the basics and basic engineering part. Many times what I find, I was discussing with Professor Garg also, that I find many times with the students when I am discussing with them, the basic engineering, suppose I talk about the strength of materials, I talk about the machine design, I ask them simple question, you tell me the gear design in a gear, how come the hardness of outside is harder and the core is softer? What is the mechanism? Why it is so? Or tell me the cam mechanism. You will be surprised to know in very, very good institutes, they do not able to explain me the plastic limit. They are not able to explain me the stress strain curve of the mild steel and the iron. Those things, your student will not be having the problem. And this basic understanding, let me tell you, we talk about any big that Katia and NISA and big analysis software, etc. Until unless we have got the basic construct, basic understanding about that theory in mind, I think any software you use, it has no meaning. There, your strength is there. Yes, certainly. Look,
maybe Professor Paul, basically we have a mixed building, and like already we have some volume with the message or something. The person one is a
Very good. Very good.
this is already working for us. One of the please.
Very good.
This type of progress
We have to enhance it. We have to enhance it. Thank you.
I have a person so waste bullet waste. Material was done. So the diamond is also not the like that. So other this decide and government was to get this type of material.
I will tell you.
Bulletproof.
Yes, we are working on it. And recently, during the DEF Expo, we had very lengthy discussion with the Reliance Group. And Reliance Group has come out with some unentangled UHM WPE fiber. They are making a tape out of it. We are testing them. Already with our discussion collaborations, with our joint working, we are coming out with this material. Then probably we will come out of this Dynama thing. But as on date, you are right. Dynama is the only ballistic material which is very good and available. Because Dynama has got the property, the moment the impact comes, the every fiber goes into fibrillization. And due to fibrillization, the energy is absorbed. Although carbon fiber, glass fiber, they are much stronger than Dynama, but they cannot stop the bullet. Number one. Number two, you asked about the helmet. Helmet, stopping the bullet is not a big thing, but the bullet, the energy is imparted. It's so high the neck will break. So even for the 9 bullet, you can stop fired by the pistol or carbine. But the moment you talk about the AK-47, 7.6 to 39 caliber, or talk about 7.6 to 51 bullet, a machine gun, impossible. Let me tell you that I was discussing in the morning with the professors. Basically, kindly, when if you want to work in this ballistic area, in the ballistic area, then kindly go sometime to our ranges and see how the bullet is fired. Sorry to say, please do not take any offense. Most of us, we have seen the bullet firing in the movies only, where you see Amitabh Bachchan catching the bullet. But as a matter of fact, there's a havoc. One bullet, when it's fired against a concrete wall, the concrete wall is completely destroyed. Let me also tell you, even AK-47 bullet, out 4 thick mild steel plate, it makes a hole as if you have drilled it. So clean hole it makes. And if there are 2 or 3 4 sheets are there, it pierces through all the things. I am talking only AK-47. If hardcore bullet is there of AK-47 or hardcore bullet is there 7.16 to 51 let me tell you, 8 with 2 plates, it will pierce through. So then that type of demon you are handling, then you try to understand the type of material you require because the terrorists will be firing at the close range on your chest. At that time, you have to stop it. And without any trauma being imparted, because the shock wave will be traveling inside. Bullet has been stopped, but the shock wave will be sufficient enough to damage all the internal organs. Because mechanical wave you cannot stop. Mechanical wave through the solid medium will travel very well. So it is a different ball game. If you want to develop and discuss all those things also, I will invite your researchers to come to DMSRD and we'll find a solution how to go about it. Thank you. Thank you.
Thank you, sir, for your kind words and beautiful keynote lectures. So now I request all the participants and members to please join the IT outside the seminar hall. And we again gather here for 12 o'clock for keynote session 2. Thank you.
I forgot to put my title. Yeah, he should be the title. Title does not topic title.
Computational fluid mechanics.
There. I can't.
Computational fluid dynamics.
The font is waiting.
এটাই লেখা আছে স্যার, computational fluid dynamics.
And its application. That's it.
Yes, sir. Computational fluid dynamics.
And its application.
Allah. Computational, fluid dynamics
And its application.
and its application.
এটা একটু নিচে সাকারিওলা নিচে করে দিচ্ছি।
थोड़ा बड़ा करो उसको।
So that can this end to end, like end to end.
चलो स्टार्ट करते हैं। चलो उसमें आओ, वो जो ऑनलाइन पे। ठीक। So, good afternoon, everyone. Let me welcome you all to the second keynote lecture, that is keynote lecture 2 by Dr. Subhash Chandra Saha on computational fluid dynamics and its applications. So, before that, let me introduce the speaker first. So, Dr. Subhash Chandra Saha is a senior lecturer of mechanical engineering in the School of Mechanical and Mechatronics Engineering, University of Technology, Sydney, Australia. He received his PhD in computational fluid dynamics from James Cook University, Australia. Then he undertook postdoctoral training at the Queensland University of Technology, Brisbane, Australia. Dr. Saha's current research activities focus on three key areas of computational biomechanical engineering, which includes particle deposition, clearance, and penetration into the lung surfactant, red blood cell deformation in the capillary vessels and aging effect of RBC deformation, heat and mass transfer including phase change materials, solar thermal energy technology, natural convection heat transfer in buildings and other confined geometries, scale analysis for the transient flow, microfluidics modeling including inertial separation techniques. So let me welcome Dr. Subhash Saha for the keynote lecture.
Thank you. Thank you very much for a nice introduction. Yes, so today I'll be talking about the computational fluid dynamics and its application. Mostly today I'll be covering a couple of areas. I'm not focusing in one area. So a couple of areas of my research, what my group is doing in Australia. So I'll be talking about that. So if you are interested, anybody is interested in any part of my research, so you are welcome. And we can discuss further after this presentation. So here, mostly I'll be talking about three key areas. The first area is heat transfer and fluid flow. In the heat transfer and fluid flow, what we have done is, we can start from here. So this is the particle deposition in the metal foam heat exchanger. Okay, so it has lot of applications like our air conditioning system and many other areas. So how this particle actually falling here? So we did some research on that, and this is another one is the heat transfer in the attic shape building. So you know that in Australia, mostly our residential house, the roof is like that, the attic shape. Maybe in India as well, and it's actually made with tally or tin or something like this. So the main issue is the heat transfer through the roof. Okay, so heat transfer through the roof, and then we have to design the ceiling such a way that heat cannot come into the building. So that is the things we actually try to understand how actually fluid flow moves or flows inside these triangular cavities and how the heat transfer happen. So we did a lot of modification of the geometry. This is actually we put some partition. Okay, partition here, and we thought like maybe the sun is here, the sun rays coming here and making heat here. This is the other side of the building. There is no sun. So this is the 3 dimension of that, and this is another case of OAB partition. So where it is, we call it infinite conductivity. So that means, so this wall actually separating two fluids. The fluid cannot move from this side to the other side or from this side to the other side, but heat can move easily. That's why we call it infinite conductivity. It has very high conductivity. Heat can easily move. So we took 2 different types of fluid here. So hot fluid here, actually cold fluid here and hot fluid here. And then we try to understand the boundary layer development along the ABC. So this is another case, and the next case is here. It is like some microchip, like a computer processor. So how the heat actually dissipate everywhere, and how can I cool the processor. So this is one work, and this is another work. You see, it is related to PCM, faceless material. And from my India visit this time, I actually visited a couple of institutes here, and I found the researchers here in India, they are very interested in PCM, faceless material, because it has a lot of application. So when I started this research, my intention was to like heat storage. So there are many ways of heat storage. So this is a very nice way we can store the heat or thermal energy actually for future use or later use. So I'll talk about this one a little bit later. So that is actually the summary, and then I'll go in details. So this is another one, is how we are doing, like using the solar energy. We are actually getting the hydrogen fuel. So we are separating the water, and then we are getting hydrogen and the oxygen there. So these are my heat transfer. I have some more, but that is the main areas what I am doing now. And this is the red blood cell aging effect. So this project actually, it was funded by Australian Red Cross Blood Service. So what happened is, Australia Red Cross Blood Service in Australia, when we collect the blood, what we do is we actually separate the blood components. Okay, so in India, and I know in Bangladesh, what happened is, if you need some blood, you call some donor. So they give the blood and you can directly take the blood. But actually we are wasting. Maybe some people only need like a red blood cell. They don't need plasma. They don't need platelets. Okay, so we are wasting. So that's why in Australia, the Red Cross Blood Service, when they get the blood from the donor, they separate all the components. Okay, for example, this time is dengue here. So if platelets, a number goes down, you need to give that. Okay, so you need platelets. You don't need red blood cell. Okay, so but what they found is, they take this blood and put into the fridge with 4-degree temperature. But they found that normally we know the red blood cell, the lifetime is 120 days. But when they put in the fridge, it actually within 40 days it become old. Okay, so they don't know why it is happening. They don't know why it is happening. So that's why they came to us and told us, can you explain it? Or can you make some modifications so that we can extend their longevity? For example, like maybe 2 or 3 or 4 days. That actually save a lot of money. Okay. So to understand the physics, we got this project, and it's called ARC linkage project. So we started working on it. You can see here, initially when the blood actually comes from the bone marrow, when it is in the bone marrow, it has the nucleus. That is the only cell in our body who does not have nucleus. Okay. So when it is in the bone marrow, they have nucleus. But from the bone marrow, when it comes to the blood circulation, they remove the nucleus. Okay. And they start flowing in this. So you can see that's why a shape is like a disc shape, no nucleus inside. And after 1 week, you can see in the storage condition, it becomes older. Okay, it is not like a disc shape. This is actually the real shape. So they become older. After 3 weeks, it's a lot of spikes. And after finally, it's so rigid. You can see the red blood cell is very, very soft. Okay. So that's why when it flows through our through the lung, the lung capillary is the smallest capillary in our body, very, very tiny capillary. So the red blood cell diameter is 6 micrometer diameter, but the capillary diameter is maybe 3 or maybe 2 micrometer. So very small. So what they do is they squeeze a lot to flow through the capillary. So when they squeeze a lot, their membrane, okay, expand. That's why the transportation happens. The oxygen and the carbon dioxide transportation. They take the oxygen. So when we inhale, okay, and then the oxygen goes there, and they release the carbon dioxide, we exhale. So that is actually happened there. But if it is not very soft, okay, then it doesn't work. So it will be separated through the splinter. Okay, so that's why we did some study, and here we did some modeling. We took the that is actually the experimental observation. Then from here we took some what is called a geometry, created the geometry, and then that is actually coarse grain red blood cell membrane model prediction. So that is our prediction, and then we did a lot of simulation later on. And the left side is the particle separation. So the thing I already explained to you, when you separate the blood component. So the existing technique, I'll also talk this on a little bit later, but existing technique, they actually spin the whole blood with a very high speed. So because of the very high speed, and red blood cell is very soft, sometimes it's damaged. So that's why they also, the same group, the Australian Red Cross, they just came to us, they told that, is it possible without using the electricity and that system, can you use something else to separate this? Because they claim that some developing country like Bangladesh, India, some African countries, we don't have uniform electricity supply. So if something happened, no electricity, how can we separate it? So based on their requirement, what we have done is we use the normal gravitational force, okay, and we use some spiral types of geometry. So that we are releasing the blood here, and then they follow some fluid mechanics like a DIN number or this kind of forcing actually applied, and at the end, based on the particle size, particle shape, it goes different areas of the channel, and then at the end we can separate it. Maybe the small particle goes this way, the larger particle goes this way. So I'll show this on a little bit later. And my third project is lung particle interaction. So that is the project I'm collaborating with Dr. Paul here. We have very successful collaboration now. And this project is, what we are doing is here is also we have 3 mini projects here. So main is this is the our computational fluid dynamics project. What we are doing is we are collecting the CT scan image from the hospital, okay, and then from the CT scan we are creating this geometry, and this lung geometry. So this is the, after doing some processing, this is the CT scan image, the lung, it looks like that, and then for further improving we are getting this geometry, and then we are releasing particles, and we can see where those particles are deposited. I'll explain that on later. And now the second project of this is particle interaction with the lung surfactant. Okay, so in the lung alveolar, we have a layer. On the top layer is called lung surfactant. So the lung surfactant, actually, that is very important component in our body. So that is the component at the end is developed when you are born. Okay, so in the newborn baby, lung surfactant, it grows when they are in 32 weeks after that. That's why if there is any newborn baby who is born before 32 weeks, it's a very dangerous for them. So they have to put them somewhere very secret place so that the surfactant grow and then they can survive, they can breathe. Otherwise, if there is no surfactant, then the surface tension very strong. If the surface tension very strong, they collapse, cannot move. Okay, but if they are still if they have surfactant, what happened is, I don't know whether you have seen or not, but I have seen my baby, because we are allowed to go to the hospital when the baby is born. So what they do is, when the baby is born, they just take the baby out, and then they put something in the mouth and they shake it, and then the baby cries. When the baby cries, means their surfactant actually expand. Okay, they start breathing. So that's why surfactant is a very important component in the lung. So here we want to see how these particles actually interact with the surfactant. There are a lot of components. I'll talk that on later on. And the last one is the particle clearance. We call it mucociliary clearance. So what is mucociliary clearance? Because every moment we are inhaling a lot of particles. Those particles are very, very dangerous in our body. So what is happening is, when you are inhaling, in our lung, we call it conducting region. Okay, conducting region, what is happening? We have a mucus layer. Okay, very sticky mucus layer. When the particle go there, it actually deposit on the surface. And then underneath the mucus layer, there is called the brush-like structure. And that actually works like this, one way, always doing like that. And that actually removing the mucus, and it's coming here. And when it is coming here, it's actually irritating this part, and we are actually eating that. And you can also feel every maybe 2-3 seconds you are eating it. Okay, so this is the way particles are clearing from our lung. But if some particles are very toxic, or their shape is like what we found is like a spike shape, it can penetrate and it can go to the epithelial, and then it can go to the blood. So that is dangerous. That we want to do it here. Okay, so these are the summaries, and now I like to talk about a little bit more about the heat transfer. Here, my first project, my PhD student was doing this project. So this is actually is a solid gas flows in porous media. So if this porous media is a real porous media, we have some obstruction here, the core here, and we release the particle. So we actually studied 2 types of particle. One is the sandstone and is sawdust particle. And we actually compare which particles actually falling is more. Is it sandstone or the sawdust particle? So we set up this one with the inlet velocity of 0.1 meter per second, and the particle diameter is about 50 micrometer. Okay, so this one, what we found is the deposition fraction and pressure drop increase with time. Okay, so now you can see from case 1 and case 2, and this both two cases, what we found is you can see here the deposition fraction for case 1 is 92.13, but with time is actually decreasing. That means some more space is covered by the particles. Okay, but but for sawdust particle, it is actually less. So this actually deposit more. Particle falling for sandstone particle is more compared to the sawdust particles. Now here we did some more analysis, and we found that for two different particles with a different velocity, we found that For this case, for like when the velocity is 0.1 meter per second, sandstone particle has more deposition fraction. It more actually deposits. And then we call that is only for the monodispersed particle, like the single size particle. And here we consider for polydispersed particle. So that means different size particles. That is actually more realistic here. So here you also found that the efficiency is 90.46 for sawdust particle, and for sandstone particle is 86.38%. Okay, so more particles are deposited for this case. So then we move to the 3-dimension. So what we did is that is actually the realistic the metal foam heat exchanger, and then we took the 3D scanning, and then we just actually create the geometry. So this is the geometry, and then we did for these two tests, and we also found very similar scenario. I'm not going in very detail. Okay, and then the next came is like, how can we mitigate this particle falling? How can we remove this particle? Because currently what we do is we open the air conditioning and we clean up manually. So can we do that without opening that like automatically? So that is the particle mitigation technique. So to apply those technique, we use like some pulsatile flow. Okay, we apply some pulsatile flow, like a sinusoidal pulsatile flow. And here, that is the last one. What we did is we introduced a heat transfer. So that is the most complex problem I faced when I solved it, because it is a conjugate heat transfer, and you can see the particles also get heated. Okay, this side is heated, the pore side is heated, and the particle is falling from here, and you can see it is also become heated. So this is very complex problem. And now the phase change material. So phase change material, why we want to use it? Because of the saving the energy. So in Australia, so energy usage at home, you can see it is actually we are using for heating and cooling the maximum 40%. Okay, and we are using like freezers 8%, water heating 23%, and cooking 5%. So this is the scenario we are using at home, this kind of like energy. And then out of this 79, it's actually 2017, and in 2016 you can see the fossil fuel we use about 83%, and renewables in Australia we are using 17%, but in 2017 it actually reduced from here to there. Okay, so that's why it is actually reducing. Fossil fuel is reducing and renewable is increasing. It is not, I don't have the recent data. And what we are doing is for the fossil fuel, what we are doing is we are using, so here we are, what we are applying, or we are applying it in many places like this. And then, sorry. Here, so in New South Wales, that is the city of the New South Wales is Sydney. So from where I am, so I want to focus in this area. So the New South Wales climate change policy framework sets out the aspirational long-term objective of New South Wales to achieve net zero emission by 2050. So that is our target. So by 2050, we want to make net zero. So we don't want to use any fossil fuel. Okay. So the way Greater Sydney's urban structure and build form develop over time can support New South Wales transition towards net zero emission. So that is what we are expecting. And we are actually going very close to that time. So here you can see a very nice dialogue. If we use the available renewable resources in the Sydney region, we do not need any fossil resource anymore. That is actually true. But it actually making a lot of trouble nowadays. You know why? Because we have a lot of sun, and the sun is very strong in Sydney or in the Queensland region. But the problem is, in the daytime, almost every house they have the solar panel. So they are in the daytime, when they get the solar, they actually selling this on to the grid, the main grid. Okay, so all the leftover, suppose you are using at home, the leftover energy, leftover electricity, you are selling back to the provider. But what happens is, the provider sometimes what happens is, they get more than their capacity. Okay, so that means we are producing at home more than we need. That actually make a lot of unstable to their system. Okay, it sometimes crash, their system crash. So that's why they need better policy. How can they do that? So for that one, they are thinking about how can we store this energy, okay, for nighttime use or for some other days use. So you see, the battery can't solve the world's biggest energy storage problem. No, they can't, because these two things, fluctuating solar and wind power, require lots of energy storage, and lithium-ion batteries seems like the obvious choice, but they are far too expensive to play a major role. The batteries are very expensive. You will realize when you buy the electric vehicle, every 7 to 8 years you have to change the battery, and the battery is very expensive. Okay, so maybe 7 to 8 years is okay, you can drive very nicely, but after 7 to 8 years, when you change the battery, you will realize how expensive it is. All right, so challenges remains in understanding energy storage as an investment. So what is the way we can do at this moment? Thermal storage like the water, molten salts, or other fluids, or compressed air, or hydrogen, or something else. So this is the way we need to think about it. And our research is mainly like some PCM, molten salts is one type of PCM. Okay, so PCM, I think you already know. I don't need to introduce too much. So PCM, you know, that have got high melting or solidification heat capacity, and phase change process occurs at almost constant temperature, and PCM can actually absorb or release a large amount of heat at a rather constant temperature. So the phase change material, you know, that the water ice is a very good material we can use, but 0 degree temperature water we can't use anywhere. So that's why it is not used. So we have to find out some PCM with the melting temperature is important. So it is now available in the market. You can buy the PCM, the melting point you want. For example, we are using the PCM at home, okay, home ceiling, because in Australia, our ceiling, we have a lot of insulator on top of the ceiling. So those, instead of using those insulator, you can use the PCM. For example, 23 degree temperature melting point PCM. If you can put on the top of the roof, not roof, ceiling, what happens is when the temperature rise, for example, about 10 or 11 o'clock, then the PCM will absorb the heat and start melting. Okay, so maybe if we can somehow survive for 5 to 6 hours until 4 o'clock or 5 o'clock, then after that the temperature reduce in the environment. So by that time, when the temperature just come back to 20 degree or 19 degree, so they start become solidification. So this is a natural process, and you don't need any like air conditioning, any fan, because you are getting always 23 degrees Celsius temperature. Okay, so this is the concept. US, they are using it a lot, but Australia is a very new, but some people they have already started using it. I don't know in India whether they are using it or not, but Australia they started using, but it's a bit expensive, but it's not very expensive. So it is now per square meter is $110 per square meter. So it is like one time. If you buy one time, it will be for 100 years. So not a problem if the surface material is good. So here is a very, very basic concept. You can see initially, for just think about the ice. So the ice, before ice, you need to give like a heat temperature. For example, the ice temperature is maybe minus 10 degrees or something. And then you heat. When it becomes a 4 degree temperature here, then it starts melting. When it starts melting, temperature does not increase. It's a constant temperature. Okay? Constant temperature, but it has a lot of energy. There is a lot of energy. So that's latent heat. And then when it becomes water, then it still, if we heat it, then it becomes vapor. Okay, then start temperature. So that is a very simple concept. So this is the reason we need it. Okay, this is if we can enlarge this time, that is the important. Yeah. So these are some applications. So we applied many different configuration. We published a very nice journal, mostly applied thermal engineering journal. Here are some application. What we wanted to do is we put some conducting materials here, high conducting materials for the way to melt it quickly or to absorb the heat very quickly. And here is a single PCM. Later on, we use a different shape, and then we use different types of PCM, not only one PCM, two different types of PCM. We applied different thermal. So we applied many different types of boundary condition. We applied, and we got very good results. Okay, but now our focus is we are using applying this technique for our battery cooling, for like a hybrid car or your electric vehicle. Because in the electric vehicle, the problem is when you charge the battery, we use fast charging because you cannot wait for a long time. You have to charge very fast. So when you charge very fast, it actually, your battery becomes very hot. Sometimes it burn out. So we have to cool down the battery cell. Okay. So this concept we are using nowadays, and but I am not presenting here. I know that some other groups here, they are also working on that similar project. So here, this is the plate heat exchanger. One of my PhD students, he works on this project. So this is, you can see, I think you already know how it works. The plate is, they put it like very compact, and they put like two different types of fluid. One is hot fluid, one is cold fluid, and this is the way they maximize the heat transfer through this compact heat exchanger, plate heat exchanger. So the main, it is very old concept. It was actually developed in 1880 or sometime, a long time ago. So actually it was made of flat plates stacked upon each other inside a frame. Okay, this is. And the first application of plate heat exchanger was in dairy industries. Very interesting, in the dairy industry. Okay, and now you can see this application. It's a huge application. Now they are nowadays using food and beverage, the pharmaceutical, textile industry, the marine, the paper industry, the power industry. Many places they are using the plate heat exchanger. So this is the what modification I did. We use some to increase the surface area. We put some corrugation. It's called corrugation plate heat exchanger. CPHE, corrugation plate heat exchanger. Okay, so this is the way we design it. We vary this angle. This angle is called the chevron angles. We change it, and we just observe the better efficiency, to calculate the better efficiency. And it's very quick moving. Yeah, here you can see we developed a correlation sheet. So this is for the basic one, the Nusselt number correlation. I think you know that is the heat transfer. The heat transfer, the Nusselt number correlation. This is for the basic one, and this is for our newly developed corrugated plate heat exchanger. We developed a new correlation for the Nusselt number. Okay, for 60 degree chevron angle on the right side and the left side. And for 30, we also developed a new correlation sheet here. And what interesting thing is, in the tabular form, you can see our improvement. We have 75%. We got the improvement of our heat exchanger. You can see here for the normal, the basic one, we have 58.3 Nusselt number, but for our revised one, we got 102. So the efficiency is more than 75%. Okay, now the last part is the I don't know how long my presentation will be. Okay, thank you. Thank you. So this one is the particulate matter transport, deposition, interaction with the lung surfactant, mucociliary clearance, a realistic CT scan based lung airways. So this is you can see the scenario here. Do you know where it is? It is in Dhaka, and you can see this one in Delhi. Okay, so it is very, very dangerous. I'm getting some email from Australian government. They avoid visiting Delhi. The air pollution is very high. So because of the air pollution, what it can happen to our body, because a lot of people, they are doing a lot of research, but very few people, they are doing research for how it is interacting directly our health. Okay, so that is the main important area of research. So here, what I just mentioned before, we collect the CT scan data from the hospital, okay, and then we do lot of post processing. It's not like a single click processing. We do lot of post processing, because sometimes when you do post processing, some part actually disappear. Then you have to reconstruct again. So you can see here that is actually the lung. Yeah. So that is the main lung area. Okay, and then after modification, you can see still there are some missing. Okay, this is the missing point, lot of missing point. Then we have to reconstruct this part, and at the end we get the geometry. Okay, and then this is a very recent one that Dr. Paul actually collected this CT scan image from a local hospital here, I think in Allahabad, and sent to me, and we did lot of post processing, and it is the complete lung, you can say. Okay, so that is the nose, and that is the mouth. Okay, and from here is the trachea, and we have all the branches. So do you know how many branches we have? So if we consider this one as a 0 or 1 or something, you can say, we have from 1 to 2, 2 to 4, 4 to 8, something like this. So we have 23 generation. Okay, we have 23 generation. We call it generation. So 23 generation means it has how many outlet? Is about 2 to the power 23 outlets. It's very long. If we connect one by one, it will be about maybe 350 kilometer, right? It's about 350 kilometer long, the lung is. Okay, so we just recently actually developed this, and we did preliminary works on this, because this is the very, I can say this is a very realistic geometry we just got, and it looks like this. And recently we did some work. What we did is, when I was very young, my dad always used to tell me that during winter, always wear a muffler. Okay, the muffler here. Otherwise, you can get cold. So that time I didn't know that how can you get cold if we do that. But when I did the research, I realized, okay, yeah, it is important. You know why important? Because, for example, your body temperature is 37 degrees Celsius. But if we inhale more than that or less than that, what happened? The heat transfer started from here. Maybe more than it started from here actually. Okay, so when it started from here, so if it is very cold, okay, if it is very cold, if it comes here, the heat transfer started with your 37 degrees your body, and maybe 4 degrees outside. So the temperature gradient is very high. So heat transfer happening, and if somehow that cold air goes inside your alveoli, you will be in trouble. You will have bronchitis. Okay, so somehow you have to protect yourself. But our lung is designed very nicely. Generally, what we found here is, when it comes like even 4 degree temperature of air, when it comes here, it already becomes 35 degrees. Heat transfer is very, very quick. Okay, so that means it does not go with the 4 degrees to the alveoli. So we are safe. So that is our first research we did. And this is the another, it is still in the testing. You can see we are actually inhaling through the nose. So this application actually we got this idea mainly I got from India. So you know that the COVID vaccine and also the COVID medicine India developed and they got the certificate to use it. That is the nasal delivery. Okay, now you don't need a injection. Okay, you can actually take it and spray in your nose like the inhaler or something like this. So it is. So that concept we are using because they developed this device very fast. We want to actually make sure that whether we can improve their concept or not, because what type of particle they are using, what shape of the particle they are using, and where actually we need to send those particles in our lung. We need to do some further investigation. So that's why we started working on this project. So here we did some preliminary studies. Actually, we submitted to a conference, and later on we do some further study, and then we can submit to a journal paper. Okay, this is another geometry. We got it is a different way. We just derive the geometry. It is not very realistic. It is realistic plus we did some artificial things to make it larger. It is 17th generation, and the previous one is about 15th generation. So that is we tried to extend the generation number by artificial adding something. So you can see here I was talking in my first talk that how expensive it is in terms of computational. You see what is the how many of 34 million unstructured tetrahedral cells we use. It's a huge amount. So what happened is we used about 64 processors, 64 computer to solve one problem. It took about 1 month to solve one problem. Okay, so it is very expensive in terms of computation. That's why now we are planning to use machine language. Okay, so machine learning technique. So in that machine learning technique, what we want to do is we want to introduce maybe 500 or 1000 particles. Okay, we'll introduce there and we will train the system, and then if they are well trained, then we can use millions of particles. We don't need to realistically solve the problem. The artificial intelligence can solve it for us. Okay, that is the new technique we are using. So here we are using some pressure and velocity contours. You can see here, and then we try to find out how the pressure dropped from generation 1 to the 17th generation. So how the pressure is dropping. The pressure drop has a very big impact for our inhalation and exhalation. Okay, and then we did the study for 2 different particle size. One is 1 micron size particle, one is 10 micron size particle. So 2 different size particles. So there are some there are like 4 types of deposition happen. Okay, it's totally physics based on the size of the particles. The larger size particle, generally it actually deposit in our nose here, because we have a lot of hair inside the nose. That actually protect us. Larger particles deposit there, like the heat exchanger. Okay, they protect us. And then the smaller than that particle actually goes and they deposit in the upper air, like a larger particle here. They mostly they deposit. They don't go like any lower area. They deposit here the 10 micron size particle. But 1 micron size particle, they go to the deeper areas. Okay, so that's why they call it like a 2.5 micron particle. They call it ultrafine particles. So below that particle size is very harmful for our body. It goes even to the alveoli. So that is very dangerous. And then we did some nano-sized particles. So that is 1 nano-sized particle, one is 10 nano-sized particle. So that the scenario for nano-sized particle is totally the opposite because of the different physics involved here. So because of the nano-sized particle, the Brownian motion actually dominates the flow. So that's why we can see the 1 nano-sized particle that will deposit everywhere, but the 10 nano-sized particle upper area, just opposite. And now we did for polydispersed particle. Those particles we talk about is just single size particles. Now it is polydisperse particles, different size particles, and the particle length is from 1 micron to 10 micron size particles. And you can see the larger particles all are deposited in the upper area, and the small particle deposit on the deeper area. And then we try to develop some correlation, and we just develop very nice correlation from 1 micron size to 10 micron size particles. So that means if you want to see what happened for 11 micron size particle, we can use directly this equation to solve it. And the I square value is very close to 1. So that means they're very accurate. And then there is another application is called the targeted drug delivery. So targeted drug delivery means you know that in every medicine there is a side effect. Okay, so when you eat any medicine, it should have some side effect. It is not exactly working the purpose you are eating. Okay, so to avoid those, what we actually did is for example, we have some issue. If we know the issue, maybe here. So what we happened is we created some magnetic field. We put some magnet here, and then when you inhale that magnetic particles, that actually goes there and deposit here. It does not go other part of the lung. Okay, so that's called targeted drug delivery. So that is now is very popular in medicine section. So they are actually trying to avoid the side effect. They are trying to give something like a targeted drug delivery for the to damage the cancer cell. Okay, so this kind of thing. So they are using targeted drug delivery system. And now this is the gold nanoparticles. The gold nanoparticles, when you inhale some gold nanoparticles, it actually can work two ways. One is like polluted particles, the naked gold nanoparticles, the people who works in the gold industry, okay, or the goldsmith, we call goldsmith, right? Yeah, they also inhale a lot of gold particles. That actually dangerous for our health. And also nowadays we are using the gold nanoparticles for drug delivery. We are coating the gold nanoparticles with the drug, and then we can send it. And that because it is biocompatible, that's why you can use it. So here we have done a lot of study on that. My PhD student recently finished. So we start using one single particles here, gold nanoparticles, and then 9, then 16, then 32. So we found that for 32 gold nanoparticles, there are some pore formation happening. That means the lung actually damaged. Okay, alveoli actually damaged. And all the other components here, it's called a lung surfactant. So lung surfactant has some components. Okay, it's called POPG, POPC, lot of cholesterol, and also it has a protein, lot of materials there. So they actually interact with these gold nanoparticles. Okay, and it also has some hydrophobic, hydrophilic behavior. And then we can see that the pore is forming. Okay, so this is a single gold nanoparticles. When they interact with the surfactant, we can see they actually cannot penetrate here, because for penetration it takes actually lot of energy. So that energy actually they can get if the particle is toxic. Okay, that time they get lot of energy. So it actually interacts over there, and underneath is water layer. And now it is that is a 9 by 9. 9. It should work. Yeah. So that is 9 particles. Still there is no core is forming. So that is it is not actually computational fluid dynamics. So use coarse grain molecular dynamics simulation. Okay. So it is actually very expensive as well, molecular dynamics simulation. So I'm showing the last one. So that is the 16 and 32. These are 32 particles. You can see the pore is forming here, damaging the lung. So if you have a lot of particles, if you inhale, that actually can damage our lungs. So this only took 6 months to solve our problem using 62 processor. So this is the most expensive result we have. So now the other one is Professor, the professor, just a keynote speaker, he mentioned that they developed some COVID-19 medicine. But before that, doctors actually found that there are some steroid medicine which is very cheap in the market, maybe 10 or 15 paise per tablet. That was very effective for the COVID-19. Okay, so the doctors are very worried that because it is very cheap, so people can have a lot. So we wanted to just test what is the effect of the dose if we take more, what happens. So here we use the drug. Okay, so the drug, we found that 5.9% of the concentration is okay, but more than that, lung actually collapse. So the monolayer becomes a bilayer. So lung actually collapse together, and you can see here. And there is a video here. Is it collapsing? Yeah. And more than that, they are collapsing. Mostly it's collapse for when it is exhalation, when are releasing. Okay, exhalation, not the inhalation. Inhalation means lung is expanding. We are taking air, expanding, and that is when it is collapsing. Okay, now the mucociliary clearance. The one I just told you before, how it looks like. So here you can see we have this kind of brush-like structure, like underneath the mucus layer. So mucus layer is here. Underneath the mucus layer, we have this. So it actually move. You can see here, start from here, it's taking this way, okay, taking the mucus this way. When it comes back, it is coming back this way. So what we did is, that is this profile is about 12 profiles. We actually got it from the experiment, Singapore National University. We got this profile, and then we develop our model, okay, and try to see how it works. And this is the model. This is the model setup, and at the end we got this one. Can you see the movie? Yeah. On the left side is the 3D. You can see this how it is working. 3D is moving. That is the realistic mode. And here, if the cilia has some issue, okay, so they only move one way. And this one is totally, it cannot bend. It just comes like this one. It cannot remove the mucus at all. So when you have the issue, it behaves like this. So like the people who has a COPD or even who has asthma, they have like a shorter, these things, a shorter the cilia. If you have shorter cilia, it cannot remove the mucus, the particles. So that's why you cannot take breath. Okay, so you have some breathing issue. So our next target will be, I don't know, so that is a very big dream. So maybe in future we want to make some artificial cilia. Okay, so who have some issue, who have some cilia efficiency, we can put the artificial one and it should be all right. So that is our dream. I don't know. Okay, the last one is blood cell separation. I told you. Yeah, so that is our conventional way. How they do is, you can see here, when they do all the spinning and at the end they found the plasma is on the top, and we have a buffy coat is here, and the bottom we have the red blood cell. Okay, and then we can separate from here. But that is not on the one because it actually damages the red blood cell. So that's why these things happen. What is inertial microfluidics? Okay, so using lot of fluid mechanics here. Okay, fluid mechanics and the particle dynamics. So all together we actually solve the issue, and you can see that looks like. Oh, battery running low. Yeah, you can see here, if the particle released from here, when it is coming here, you can see the total particles are separated. And then it's coming one way. So this coming this way and this coming the other way. So this green particle is called CTC, that the tumor cell, okay, the cancer cell. So cancer cell is easily separated within this concept. So this concept actually already commercialized, and they develop a machine, and this machine is in the hospital. So they can actually, what they are doing is, if somebody has some blood cancer, so they keep taking your artery, they are bypassing your artery through the machine. Okay, so your blood is going through the machine and separate the CTC, and the rest of the blood going back to your body. Okay, if the machine goes for 1 or 2 hours, your body will be free from the blood cancer cells. This is some experiment. You can see the CTC is moving this way. And sometimes we need to separate some plasma because we need to give some plasma therapy. There are a lot of disease who needs the plasma therapy. That is the same technique, but geometry is different. Okay, so they can separate this way. Thank you very much. Any questions?
Yes, I have a question. Why the efficiency of separation of cancer cells in the mechanism of the machine which you have developed? The machine which is developed for separation of blood cells, what is the efficiency? How it is the complete cancer cells have been separated?
All right. So recently we published a paper to fluids, and the efficiency I found is 98%. 98%. The particle is not more. We use only 20 particles because, as I told you, if you use more particles, this competition is very expensive. So that's why we are using some machine learning technique. But from this 20 particles, out of 20, we took like 6 or 7 white blood cells, the larger particle, and red blood cell is the rest. And then at the end, we found that one particle and the other particle, all the particles removed, white blood cell, only the one particle goes with the red blood cell. It's about 90%. 90%.
For a cancer patient, even this 2% cells will be very much tender.
That's why you need some time to go to there and they have to do the bypassing thing. If one cell is there, it can actually multiply. But if you're lucky, it can be 100%.
It will not prevent the formation. It will not prevent the
No. It only can separate from the body. No.
patient has to go again and
Yeah, again. Yeah, like a diet.
My basic question.
Yeah.
Machine can be used for battery based.
Yes.
What is the limitation of this?
Yeah, we did a lot of study recently because we are using it and we want to learn more about it. So what we are doing is, what is my plan is not actually the real scale. Okay, real scale is Paul and his team. They are doing here. One student is working on this real scenario. It's called hybrid. They are using hybrid technique. Coolant as well as the PCR. But what we are doing there is, we are considering a single battery cell, which is embedded by the PCM. So we are using multiple layer of PCM or some like a conducting different theme or this kind of way. We want to see how quickly we can dissipate the heat from the cell. So that is the technique. It's very fundamental. It's not realistic. We are not applicable here. So we are doing very fundamental research.
What is the limitations and what temperature, like in the BS6 technology, we need in just processing systems, we need a particular temperature at a TGP side.
Yeah.
So sometimes we require a 120-degree temperature for removing the NOx gases from the exhaust.
Yeah.
So can we use the reversal process instead of the cooling? We can use as a heat sink.
reverse into automatic, because when it is you are charging the battery, after that the temperature goes down. So that means the PCM will getting the certification again. So we are using like only not high like 100 HP. We use maximum 55 RT 55. We call RT 55 means melting point 55 is temperature. We that is the only one we use maximum. But for the particle layer and particle wall, a lot of interaction will come, but not for the lab.
Second part of the question is for a beginner who want to start the work in this area. This work, the work you have presented is done in commercial software, for example, CFX or maybe console, or maybe your own code. So what are the challenges there? And what are your suggestions for the beginner to work in this area?
So that is very good question. Very good question. So I think for the students is very important for them. So CFD, computational fluid dynamics, what I call it like the image looks very fantastic because it is 7 colors are there. It's very colorful, looks very fantastic, but it doesn't mean that it's physically correct. Okay. So when you solve any problem, when you get any results, we have to physically interpret it. So they have to know how this problem is solved. So now because of the availability of all the commercial software, so now the students, they got some shortcut way of doing it without knowing the main, how the differential equation is solved, how the discretization happened, how the boundary condition mean. For example, we use like in the wall, when the particle actually hit the wall, it actually deposit there. We use like a trap condition. The coolant has a trap condition. So what does it mean? Trap condition means when it is going there, the velocity is zero. It is not moving. So they need to understand the mathematics of it. Okay. Otherwise, it is very hard for them to get correct results. So and I found especially for undergraduate project student or even some PhD students, they are doing CFD but they don't know CFD because they are presenting what the software is giving them. They cannot actually physically interpret that. Those. So that is very dangerous to use the commercial code.
I consider the energy storage product.
Yes.
We have mentioned lithium-ion batteries. The major role of lithium-ion batteries is the expensive.
Very expensive.
But for developed country, the cost is not. The matter is that the natural limited natural resources. For cost, especially lithium-ion battery, it is related to developing country.
Developing country.
Yes.
The battery.
Issue.
Yeah, issue is the development. That's what I said. Not only developing country, the developed country as well. Because I'm building a new house. Okay. So I was actually thinking that I'll store the battery, the energy into the battery. The daytime is used at the night time. But the Tesla battery, I talked to them, it's very expensive. And after 780 years, you have to change it. So I'm not going to do that. So it is very expensive. So that's why we have to find out a different way. There are lots of research going on. Some people, they are doing like during the daytime, they are heating the water and putting the water underneath the soil. They are making a very big container underneath the soil and hot water, they are sending that. And at night time, they are taking the hot water for like their hot water system or this kind of thing. So there are a lot of ways they are now storing them. But battery is really expensive.
Recycle reuse is also a big challenge.
Recycling is also the challenge. Okay.
So thank you, sir, for this wonderful talk and giving us a lecture on the multidimensional applications of CFD. A big round of applause for Dr. Shah for this wonderful talk. Now it is the end of this session, and I will invite all of you to have lunch outside.
Next